Hello students, this is our lecture number 9 and today we will discuss some of the common CPU scheduling algorithm and some advanced CPU scheduling algorithm, right? So out of this, the some of the common CPU scheduling algorithm, the numerical and all we have already discussed in our previous session. So today it will be a kind of very brief and something kind of revision. Okay. So basically, from the process state diagram, you have come to know that CPU scheduling algorithm is also known as a short-term scheduler, who is responsible for transferring a process or a job from a ready state to running state. So it's a very important because it is the algorithm who keeps the CPU busy all the time, provided there is some process who is ready for execution in the ready queue. So first, one of the most common CPU scheduling algorithm is the FCFS algorithm, is also known as the first come first serve scheduling algorithm. In first come first serve CPU scheduling algorithm, the processes are given to the CPU or CPU is given to the respective process based on the arrival time of the process. Now, if the arrival time is same, then it will follow the order, right? So we have seen several numericals on it, in which we have given a CPU to the respective process based on the arrival or based on the order if the arrival time is same. So whoever process comes in the reaches the ready queue first, that will be given the first preference for CPU to complete its task. Next is the shortest job first. It is also known as a SJF CPU scheduling algorithm. Now, in case of shortage of first, the process, the list of process which are ready for execution and is listed in the ready queue, out of the list of process, that process will be given chance of given preference for assigning CPU, which is having a minimum burst time, a minimum execution time, right? So that process is given our first preference, which is having a minimum execution time, or which will take, or which will use least amount of CPU time. That process will be given first chance. That's why shortest job first. Now there are two versions of shortest job first: preemptive and non-preemptive. In case of non-preemptive, once a process is given to once any process from a ready queue is given to a CPU, the process will not release voluntarily CPU until and unless it completes its task entirely, which means that suppose the burst time is 10 units, then until and unless entire 10 units is completed, the process will not release the CPU. Now what about the preemptive? Now preemptive means when you assign a process to a CPU, there is a possibility based on the criteria and the scenario that the currently executing process may be forcefully stopped for executing further, or in other words, the CPU will be forcefully snatched from the currently executing process. So that's why it is called a preemptive shortage of a scheduling algorithm. So it is this preemptive shortage of first is also known as a shortest remaining time first. Shortest remaining time first. We have already discussed so many examples on it in our previous session. Now, preemptive and non-preemptive scheduling algorithm could be any can be applied to any other scheduling algorithm. However, there is some restriction. Like for example, the FCFS is an exclusive non-preemptive CPU scheduling algorithm, whereas in case of shortage of first, there are two versions of preemptive and non-preemptive. Now, if I talk about the performance of FCFS and SJF, whether irrespective of non-preemptive or preemptive, SJF, the average waiting time is less than the FCFS, which means that FCF is efficient than the FCFS. right? So these are the some of the common CPU scheduling algorithm. In addition to it, we have one more special type of um, algorithm called priority scheduling algorithm. Now I have classified priorities algorithm separately out here, although in my previous session you have heard that priority scheduling algorithm is one of the type or special case of SJF. So in case of priority scheduling algorithm, there is a specific attribute associated with the input values, that is priority value. Okay, each and every process is given or is assigned some priority. Based on the priority value, the process will be given the preferences. Now say for example there are three priorities: one, two, three, 1, 2 and 3. One means highest priority, two means second highest, and third means third highest, right? So in this scenario, the process which is having the 1 as priority value will be given the first preference uh, for executing the CPU, right? For using the CPU. Now why I'm saying this priority scheduling algorithm is a type of the SJF, because in SJF we give first preference to that process having the minimum burst time, and in priority we are giving the preference to that process having the highest priority, right? So it is a kind of the nature of selection of the process is almost same, right? In either case, whether it is a SJF or whether it is a priority scheduling algorithm, both of them faces a problem of starvation, okay, or indefinite blocking also, I can say. In case of SJF, or if I have to talk about the SJF, uh, it faces the starvation problem because the process having the very large burst time will never ever get chance to execute it, because there may be some process or the other process having the burst time with less burst time, right? So whereas in case of priority scheduling algorithm, starvation occurs or indefinite blocking occurs in a situation that every time there is some process coming into the system, and there may be some process which is having the very low priority, and such kind of process will never ever get a chance to execute, or in other words will never ever get chance to use CPU to complete its execution. So in either case, SJF of type preemptive or non-preemptive, in other case, or priority scheduling algorithm, there is a very high chance of encounterment of starvation or indefinite blocking. Indicates that the process with the high burst time or large burst time, or process with the lowest priority will never get chance to execute. So now this is the problem. Now what is the solution to it? It's the aging, right? It's the aging. So aging means as and when time progresses, it will try to gain the gain the chance of getting the CPU. Or in other words, if I talk about the priority scheduling algorithm, for example, in case of aging, what happens is that as and when time progresses, the priority is incremented one after another. Maybe say for example, in the initial the priority of a particular process is, say for example, it's 5, then next time it will become 4, then next time it will become 3, like that way. Okay, as and when time progresses, the priority is increasing. Now which means that there is a chance, or some at some point later, definitely the process will definitely going to get a chance to execute a process. So that is known as a aging. Now I'd like to put a concentration out here. In my previous session, somewhere in the slide, okay, so I've used the word aging out here. Maybe in the problem or the solution, you please correlate it and rectify it accordingly, right? So the problem of the SJF or the priority scheduling algorithm is the starvation problem, and the solution is aging. Starvation problem means the process with the least priority will never get chance to execute, and solution is as and when time progresses, the particular process will gain in incremental fashion the priority, and it is definite that at some point time later it will definitely get chance to execute the CPU, right? To execute the code with the help of the CPU. Next, last one is the round robin. Okay, so the first three are like if you compare it, right? So SGF and priority are almost same, and in these cases, they prove to be a good efficient one in comparison with FCFS. Now Now, in either case, FCFS, SJF priority scheduling algorithm, okay, what is happening out here? In case of FCFS, the process who is coming too late will get last chance. In case of SJF, the process with the huge burst time will get last chance, and the priority scheduling algorithm, the process with the least priority will get the last chance. Now, this discrimination is removed with the help of the or avoided with the help of the round robin scheduling algorithm. It is a very generous algorithm which gives an equal chance and equal opportunity to use the computer resources entire across all the processes available in the ready queue. So it's a very general algorithm that does not discriminate based on some their attributes or the properties. So in round robin algorithm, what is happening out here is that there is a particular attribute associated with it called the quantum or time quantum. It is a time that is given to each and every process that is listed in the ready queue. So all the process, irrespective of the properties like priority or arrival time, irrespective of the property, whichever process is in the listed or is have arrived in the ready queue, okay, all those processes will get chance to execute the CPU, right? So it is giving an equal chance, okay, but it is giving a chance for some limited time or for quantum amount of time. So quantum is assigned to the to whenever a round robin is implemented, quantum is assigned to it for each and every process to execute a task, whether it completes or not. Okay, whether the process completes or not, once it quantum time is over, the CPU or the resources will be snatched from the or preempted from the process and give it to the next process in the sequence, right? So this is very generous algorithm which uses the concept of the quantum, and with the help of the quantum, all the process will get equal chance to execute it. If it completes the time, if it complete its task within the given time quantum, it's okay. If it does not, then it will be preempted, and in the round robin fast, in the next cycle, it will get again chance with the same quantum. So this is how round robin works. Now, one of the problem with the round robin is what should be the value of the quantum. Okay, so because you cannot randomly keep the quantum value either too large or too small or any value, right? So there is some like a problem with the selection of the quantum value because it is very crucial. Okay. So if you randomly select the quantum value, say for example you have select very large quantum value randomly, right? So now if you select very large quantum value, okay, the performance shown by the round robin is almost equivalent to FCFS, and you all know that in case of FCFS the average waiting time is very large. Okay, now suppose you have selected the quantum value very small, okay, practically in practical scenario, if you select the quantum value very large, then the CPU will be snatched from one process to another frequently, right? Frequently means what is happening over there, the loading and unloading of process will be done frequently, and during loading and unloading, the time elapsed between loading and unloading of any process is known as a context switch time. So basically the context switch time is a time overhead or the wastage time in which the CPU or the computer system will not do any kind of useful work. So this is the problem mm, with the selection of the small quantum value. If you select the small quantum value, there will be too much of context switch time, and too much context switch time is very bad for the performance of the computer system because it will not do any kind of useful work during the context switch time, although it is very less. So selection of the quantum value is very small. So these are the some of the common CPU scheduling algorithm. In nowadays maybe in different ways. Some of them uses the hybrid of this algorithm. However, these are the very basic one. There are some more algorithm that the recent technology or the operating system uses is adopted for better performance, right? So in addition to this one of the basic common algorithm, there is another this is there is another class of algorithm. Okay, so multi-level queue scheduling algorithm is another class. Okay, it's another category of CPU scheduling algorithm in which the processes are grouped based on the nature. Okay, based on the attribute or the property. So the processes are basically we can easily group into two types. foreground process or the background process. All the system, clock, task manager, okay, all these basic programs or the process necessary for executing the operating system will be always run in the background process. And there are some process like interaction of the mouse, keyboard, right, or paint. Those are the examples of the foreground process. At the time of typing and all, okay, so any paragraph that you are typing in the MS Word, so all those are the examples of foreground process. So all the processes that is running in the system can be grouped into two category, foreground and the background. However, you can classify in n number of different category, but for simplicity I have taken example of foreground and the background process. Now it is also known that a foreground process have the highest priority, whereas the background process have the least priority. Okay, so which is always by the name itself, it is running at the background, that's why low priority. Foreground, by running by the name itself, it is running and it is in front of the user using it, so that's why high priority, right? So this classification can be done based on this classification. Based on the classification here, in this case, I have done only two classification. I can do 3, 4, 5 classification based on the nature and the properties of the processes. Now once this is done, what will happen is that the ready queue, okay, till now you have seen only one ready queue. Now that ready queue can be partitioned into several queues, okay, based on the partitioning of the classification of the process. Suppose in this example, I have only partitioned two categories. Now you can, based on the partition of the classification of the process, foreground and the background, you can divide the ready queue into two portion, foreground queue and the background queue. Like that way you can have it. Suppose you have divided into four classes, then you can have four classification or partition of ready queue into four different queues. Now each and every different queues are implemented with own CPU setting algorithm. Like for example, the first, like for example, the foreground queue, okay, the foreground queue is implemented using the RR, and the background queue is implemented with the help of the FCFS. Like that way you can implement it, okay. So basically processes are classified into different groups, okay, like it may be like foreground or background. And similarly, ready queue is also partitioned based on the nature of classification of process, and each of these separate queues are implemented using own algorithm. Using the own algorithm means like some out of this partition of different ready queue, okay. So one of the ready queue may be implemented with the RR, another may be SJF, another may be priority, and another may be FCF, FCFS. Yeah. Okay. So these partition queue may be implemented using separate scheduling queue. Now, oh, now whenever a process is there, okay, whenever a process is there in the job pool, the process will be selected. The process will be selected from the job pool, and based on the priority of the process, the memory size of the requirement of the process, and based on the type of the process, whether it is a foreground or background, the process will be assigned to its respective queue. The process will be assigned to respective queue based on these attributes, okay. And whenever any process is assigned to any of the queue, it will reside in that queue for its entire lifetime, until unless it gets completely executed. So you can take up the example that suppose there are list of processes in the job pool, and based on the attributes or the nature of the properties or anything, okay, so the processes are grouped into 5 categories, right? So instead of 2 classification, they have made the classification in the 5 categories. Maybe some of the processes are system processes, and some of the process interactive, some of the process interactive editing process, some of the process batch process, some of the process are student process, low priority process, okay. So the processes in the job pool are classified into 5 groups, right? And the ready queue is divided into 5 different queues. So whenever any job is brought from the job pool to the ready queue, it will see its nature, and based on the nature, like for example, suppose the priority is very low, memory requirement is very high, and the type of the process is like very background process, right, or the student process, then such kind of process will be assigned into the student process queue. So this square bracket are the queues. Okay, now there may be some process which memory requirement is very less, priority is very high, and considered to be a interactive process, then it will be put into the interactive process. So each of these queue is implemented using different algorithm. It may happen that interactive process is implemented using RR, interactive editing process is also implemented using RR, whereas student process is implemented using the FCFS, like that way. Okay, and each of these queues is implemented using different CPU setting algorithm and has its own priority. Now priority, why it is assigned, because the processes that are listed in the batch process queue can be executed only when all the processes in this above high priority queues are empty. For example, suppose there are three processes in the system process, and the priority of this queue is very highest among all. Now all these three processes that is residing in the system process has to be executed completely, then on the processes which are listed or which are residing in the interactive process will get chance to execute. So all the process in the above queue has to be empty to execute the process which are listed in the below queue. So that's why you can see lowest priority, higher priority, this kind of this is one way of implementing the multi-level uh, queue scheduling algorithm. Another way is you list all the process in the separate queue based on the nature. Then after that you apply the time quantum instead of priority. Instead of the like this priority, you apply the time quantum. Okay, so time quantum means, like say for example, you give 5 millisecond. Time quantum is 5 millisecond. So uh, time 5 millisecond is given to this queue, to the process that is listed in this queue, system process queue, to execute. Now after time quantum is over, the CPU will be given to the process which is listed in another queue. Like that way you need to continue in a cyclic fashion. So this is another style of implementing the multi-level queue scheduling algorithm. So these are the two different ways with which you can implement the multi-level queue scheduling algorithm. Now in case of multi-level queue scheduling algorithm, there is one problem. The problem is, once the process is assigned, it will not leave this process until and unless it gets executed, completely executed. Now sometimes what will happen is that sometimes what happens is that interactive process which is of highest priority, okay, suppose it is taking too much time, or while executing or while performing some action, it runs to some indefinite blocking or starvation problem. So then in that case you cannot move from one queue to another queue. So to remove this problem, okay, so to remove this flexibility problem of the multi-level queue scheduling algorithm, multi-level feedback queue scheduling algorithm is introduced, wherein the processes which are listed in this one queue can be moved from one queue to the another queue based on the performance or based on some criteria, right? So for example, all the processes are listed out here: first queue, second queue, and third queue, and these queue have been implemented using separate scheduling algorithm as usual, like I have discussed earlier in my previous slide. So suppose there is one process, okay, suppose there is one process in this first queue. Suppose there is one process in the first queue, and this first queue is implemented with the help of the RR. Okay, second queue is implemented with the RR, but with different time quantum, and the third queue is implemented with the help of FCFS scheduling algorithm. Now suppose I was talking about, suppose there is one process out here. Now that process is to be executed by the CPU, and the time quantum given to it is 8, right? 8. So now if CPU does not complete, or the process it cannot be completed within the given 8 unit of time quantum, then what will happen is that it will assume that, okay, this the process is going to take longer time to execute completely, so it will be shifted from this queue to this next queue. Now the difference between first queue and the second queue is a kind of um, um, time quantum. So in the first queue, the small process with the requirement of small burst time, the computer system is not asking such kind of process to wait for long time. So that's why if it completes within the given time frame of quantum, okay, very good, okay, it will exit the system completely, task is completely done. If not, then it will be shifted to next queue, which is having the larger time quantum. So if the process is there which is whose CPU requirement is very very large, it's a kind of a CPU bound process, or in the other words, so out of total amount of time, 80% of time is required for the CPU uh, computations. Then in such kind of scenario, such kind of process will decrease the priority from there to there to here. So like that way, the process will move from one queue to another queue based on the nature. Nature means like a low priority or very very time consuming process. So this is an example of the multi-level feedback queue, so which you can implement it later on as and when time progresses. So this is all about the today's session. So what we have discussed, a kind of recap. So we have discussed the various common CPU scheduling algorithm like FCFS, SJF, priority scheduling algorithm, and round robin. In this, we have also discussed the type of the scheduling algorithm. It can be a preemptive and non-preemptive. Preemptive means CPU can be snatched from the currently executing process. In case of non-preemptive, the process will release the CPU voluntarily after completion of this task. Now, also we have understood that the SGF and the priority scheduling algorithm can be two versions, preemptive and non-preemptive, whereas FCFS is an exclusive non-preemptive scheduling algorithm, and round robin is an exclusive preemptive scheduling algorithm. You cannot have a round robin of type non-preemptive, or you cannot have a FCFS of type preemptive. So these are the common thing that you should be knowing it. Next, we have discussed another class of algorithm, that is multi-level queue scheduling algorithm, where the processes are divided into different groups. Okay, and based on the properties. Okay, and ready queue is divided into partitions, where the different queues are implemented using different algorithms, and the processes are assigned to the this queues and are executed. So next is the multi-level feedback queue, that all we have discussed. Okay, how the process will move from one queue another, which was not feasible or which was not flexible in multi-level queue. So multi-level feedback queue provides some flexibility. It is all the features and the properties that is discussed in the multi-level queue applies to multi-level feedback queue. In addition to it, it provides one more additional feature, that is feedback. Right, feedback. You can move or shift the process from one queue to another queue. That's all. Thank you so much. If you have any questions, please do upload it, or you can have it in the next discussion. Okay, thank you so much.